Okay, in this video, we're going to walk through compensated demand. We'll talk about income and substitution effects, and we'll close out with the Slutsky equation. So what we're going to do is set up a problem you've seen before. This is the Cobb-Douglas utility function. So the consumer's problem, you've already solved this in your homework. It looks like this. QA, QB, and we're maximizing over a utility function U, which takes QA, QB, and it looks like QA raised to the alpha, QB raised to the 1 minus alpha, and then we're constraining it by the budget, which is PA, QA plus PB, QB, and that's equal to some income. And so because we've already gone through and solved this problem, we're just going to jump ahead to the demand equations. So we have QA star, and we've already found that it's equal to alpha times y over PA. And symmetrically for B, we have 1 minus alpha times y over PB. Okay, so for the rest of the problems we'll work through, we're going to let alpha equal 1/2. I'm going to leave alpha symbolic for most of what we do, but when we actually come to finding numbers, we're going to use this alpha equals 1/2 for everything. Okay, so we're just going to check a few things to get our problem set up. So let's actually go ahead and we're going to plug in values at a couple points. But before we do that, I just want to set this up graphically. Some people have asked me this when I've been doing economics all my adult life. Even I prefer starting with a graph. So here we have QB on the vertical, QA on the horizontal. And what we're going to do is, so, our budget equation gives us our constraint, and we have our indifference curve defined by our utility function. Okay. So we have a couple of points. So our first point is given our original prices. So let's check this first one. So let's say the price for A is equal to the price for B, which is equal to 4. And we'll let income equal 240. And I've already done the math here just to save a step or two. We can find the quantity for A is equal to, because it's symmetric, it's going to be equal to the quantity for B, which here is 30. I'm actually going to write this slightly differently. QB star, this is equal to 30 and 30. Okay, and that's we'll call this point E1. So this is 30, and 30. Okay. So then let's check a second point where we have the price for A equal to 16. So we've gone from 4 to 16. The price for B stays at 4. And our income stays the same. Okay, so this definitely leads towards a lower quantity, which gives us a lower utility. One thing to realize, right, and we've already shown this in one of our homeworks, when the price of one good goes up, the quantity demanded is going to change only for that one good. So here, QB doesn't depend on the price of A going up. So we already know the quantity for B is going to stay the same without even doing any math. But luckily I have numbers. So we're going to plug in, we're going to find that once we plug in these values into our demand curve, we get 7.5 and 30. And we'll call this E2. So what's happening here is we get a shift inward of the budget constraint. So we started here and we end up moving all the way in somewhere around here. So this clearly puts us on a much lower indifference curve, which we know is going to run through this point. And it's running through that point because we already know from the math that the quantity demanded of B is going to be the same. So that's kind of how we know this point. And this will be 7.5. Okay. And I should have done all of this in blue. So let's just box that. Okay. So let's just write the utilities as well. So this here gives us a utility of 30. So you can check all my work, and if you catch any errors, giving out the equivalent of virtual candy, just economics points, whatever you want to call them. I announced them in class. And the utility for the second price bundle is 15. Okay, so we've defined all the variables that are most important to us, and we've found the equilibrium quantities and defined the utility, the indifference curves we live on. So what the next thing we're going to look at is the income and substitution effects. So without making this graph look really messy, essentially what's happening with the budget, right, is our income is staying the same, but our indifference curve is getting worse. So the question is, how much of this decline in QA is coming from the fact that we're ending up on a lower indifference curve and how much of it is coming from the fact that the relative prices, the slope of the marginal, the budget, the slope of the budget, the marginal rate of transformation, how much is coming from the fact that this slope is different. So we're going to isolate both of those effects. So the first one is the substitution effect, which is if we had a parallel line to our new budget. Maybe let's do this in a different color. If we had a parallel line to our new budget, where would this point of tangency be? So I didn't quite draw it parallel, but imagine these two lines are parallel. Okay. Maybe we could draw it like this. Okay. So those two lines should be parallel. We have this intermediate point. Everything on one side is the substitution effect, and everything, let's write that out. And everything on the other side is the income effect. Okay, so what our goal for the rest of this video is to talk about these two. So to do that, we're first going to introduce, or I guess follow up on the introduction of compensated demand. And the idea with compensated demand is to ask, how much do we have to shift our income from this line out to this line? How much do we need to shift it out so that we remain on the same indifference curve? So essentially what we're doing is we're just saying, let's hold U bar constant and walk through our cost minimization procedure to place the budget tangent to the indifference curve, U bar 1. So that's what we're going to do. So to write the procedure down for compensated demand, but before we do any math, I just want to really hammer home the point that getting the intuition first is going to guide all the math we do from here on out. There are at least 3 ways to do this problem, and there are lots of variations along the way. I'm going to show you what I think is the simplest way. But if at any point, particularly on like exams or if you feel stuck during homework, being able to guide your intuition with some visuals is really helpful. And that's actually what we do in research all the time. So when we feel stuck, we go to a picture and try to work it out visually. Okay, so compensated demand solves the following problem. We want to minimize our expenditures. For some, we're not going to define the income yet, because that's going to be an outcome. Constrained by our utility. So we want to remain on this indifference curve. Okay. So what we're going to do is actually walk through sort of a simplified version of the cost minimization problem, and we'll derive the Hicksian demand or compensated demand curves. And then we'll go back, check that our original indifference, our original solution, our E1 and our new point are consistent with the utilities that we solved for. Then we'll also check this point so we can find the substitution and income effects. So that's the map of where we're going. Okay. So the first thing to do is substitute. So we'll solve for QB, which I've already done the math here, so we'll save a couple steps. U bar 1 over QA alpha to the 1 over 1 minus alpha. Okay, so then we'll substitute this in for QB and take a first order condition. So our FOC is the derivative of our expenditure. So I guess we could say that's E. So our first order condition is the derivative of E with respect to QA. And we'll set that equal to 0. So the derivative here is just PA plus. So we have, maybe it's easier to simplify this over here. So we have U bar 1 over 1 minus alpha times QA to the negative alpha over 1 minus alpha. Okay, so then here we have PB times U1. So we're looking at this, then we're looking at this. 1 over 1 minus alpha. Then we have the exponent, which is alpha over 1 minus alpha. And then we decrement the exponent by 1. So we have QA negative alpha over 1 minus alpha minus 1. Okay, that got too close. So let's jump down to the next line. I'm gonna not write out every step just for the sake of retaining viewership. That was meant as self-deprecating humor. Take it as you wish. So we'll just solve this out. I've already done all the steps here. So you can double check each of these. And then this is all equal to U bar 1 over QA, which is 1 over 1 minus alpha. Okay, so then solving out for QA explicitly, and this is our Hicksian demand curve. So we have PA, PB, and U bar 1. And this just comes out to be U bar PB over PA times 1 minus alpha over alpha raised to the power of alpha. Okay. And so what we can do is then take our QA star, plug it back into the indifference curve. So we have this thing here. We plug it back in, and that gives us QB star. And we'll just write this out in Hicksian notation. This gives us U bar 1, PA, PB, one minus alpha over alpha raised to the power of alpha. And I wrote this should be alpha over 1 minus alpha. Okay. Oh, and 1 minus alpha. Okay. Great. So let's check our original values. So the idea is at this point, E1, we know what the utility is. That's 30. We know what the prices are. Let's check whether the quantities match. And because we're saying we want to keep the income, utility, and prices consistent, the Hicksian and the Marshallian at this point should align. We get the utility coming from the Marshallian demand. We plug the utility back into the Hicksian demand, and that should give us the same numbers. So let's just check that that's true. So remember, U bar is coming from the utility function. Our Hicksian, or excuse me, our Marshallian demand, we have demand is a function of price for A, price for B, and income, which is the same thing as under full expenditure. We can plug the expenditure into this Marshallian demand. So all we're doing is we have, you can think of this as sort of the equivalent of the dual, where we either engage in utility maximization given some income, or we engage in expenditure minimization given some utility. So as long as we have everything fully defined, we know what our utility is and we know what our expenditure is, we should end up with the same quantities using these numbers. So I'm saying the same thing a couple different ways. But given our utility that we know, and we derived this from the Marshallian demand using this income, if we use that utility and plug it into the Hicksian, we should end up with quantities that get us to an expenditure equal to the income that we use to generate the Marshallian solution. Okay, so hopefully that idea works with your intuition. So let's just go ahead and calculate this. So I'm not going to walk through all the steps here, but plugging in a price of of 4 and a utility of 30 into the Hicksian gives us a bundle that's 30 and 30. And this is really just a calculator Wolfram Alpha type step. You just plug in the numbers and generate the results, because we already have the explicit forms. Okay. So when price for A is equal to 16, price for B is equal to 4, utility is equal to, well, first we're going to look at utility of 30, plug that into the Hicksian. This gives us 15 and 60. Okay, so you'll notice we've actually increased our quantity B. So why is this happening? So as we've moved from this point, from E1, on the indifference curve, maybe we'll call this E3, so this is E2. At E3, we need some compensation. So our income is no longer the same. And that's, so our expenditure at this point, so this is E1, this is E3. Our expenditure at E3 is going to be higher. So let's go ahead and calculate this. So expenditure at E3 is 16 times 15 plus 4 times 60. And this comes out to be 480. So this is actually much higher than it was at E1. E1 had an expenditure of 240, and that was from this. And you can verify that's true. Okay. So our income has gone up, but we've also substituted, we've moved along the indifference curve so that our point of tangency between the marginal rate of substitution and marginal rate of transformation is the same. So our tangent point is further up the indifference curve. Okay, so this actually lets us find the substitution effect. So our Hicksian demand allows us to find the substitution effect in this very direct way. So the substitution effect is on the horizontal axis. You could do this on the vertical axis if you wanted, but typically we mostly just look at the horizontal axis just as convention. But there's no reason you couldn't do it on the vertical axis. Okay, so here we've gone from 30 to 15, so the substitution effect this is just the difference. So this is 15. Okay. We could write it as a negative. Okay. So for the third point, so we want E2 as well. So just to verify this, the price is 16.4, but we're at a lower utility level of 15. We plug this into the Hicksian, and we get the same values, as you would expect. Okay, so that means our income effect is this difference, which is just 7.5. Okay. And just to verify that E1 and E2 have the same expenditure, we can write this out. So we have 16 times 7.5 plus 4 times 30. And we plug this into a calculator. And that gives us 240. Okay. As we would expect. Okay. So then the total effect is just the sum of the two. So we have negative 15 and negative 7.5. And sort of by construction, this is going to be our negative 22.5, which is the total effect we observed here, going from 30 to 7.5. Okay, so that's income and substitution effects. That leaves us, the last thing to cover here is the Slutsky equation. So let's do this real quick. Essentially, we're just going to use our numbers and verify this identity. Okay, so the Slutsky equation is just elasticity of demand is equal to this Hicksian elasticity and the elasticity of supply times our expenditure on the good we're looking at. Okay, so we're just going to write each one of these out and solve for them individually, and then we'll plug them in to the Slutsky. Okay, so for the first one, we have the derivative of the demand curve with respect to the price. So let's look at A, and then we multiply that by the price of A over the quantity of A. So that's going to be negative 1/2. So we go back up to the demand curve here. So I'm plugging in for alpha. So we have negative 1/2 times 240. So let's actually just make that simpler. 120 times the price of A oops. So yeah, we need the price of A on the bottom. I should write this out more explicitly. So we have Q is equal to alpha y over PA. So the derivative of this, of QA, with respect to PA is alpha y. This is a negative exponent, so we have -1, which gives us PA to the -2. So price here is 4, so that gives us 1 over 16, because it's squared. Then we multiply that by the price of A, which is 4, and then divide it by the equilibrium quantity, which is 30. And simplifying, this all comes out to be -1. Okay? So then this Hicksian elasticity is just the derivative of the Hicksian with respect to price of A times PA over QA. And just to write out this whole equation, since we got kind of stuck on this one, we have U bar times PB to the 1/2, which is alpha. And then on the bottom we have PA to the 3/2. And then we multiply this all by PA over QA. And when we plug in the numbers here, we have -30 times the square root of 4 over 16, which looks nice, and 1 over 30. And this should all come out to be 1/2. Okay, and lastly, we have the elasticity of supply, which is the derivative of the supply curve. Oops, excuse me, what am I doing? This is income elasticity of demand. We have the derivative of the demand curve for A with respect to the price for A times I'm sorry, with respect to Y times Y over QA. Okay, sorry about that. So we have alpha PA times Y over QA. And plugging in some numbers here, we have 1/2 over 4 times 240 over 30. And that's going to equal 1. So then all we're left with is this expenditure function, which is, or sorry, not expenditure function. This is the total expenditure on A. So we have PA QA over Y. And this comes out to be 4 times 30 over 240, which is 1/2. Okay. So then we're going to take these values and plug them into our Slutsky equation. So we have -1 is equal to -1/2 minus 1 times 1/2. And indeed, everything checks out. Okay. So this just verifies that the relationships between these elasticities is in fact true. That this graph is all consistent. That when we go from E1 to 2, this intermediate step of E3 that the compensation, the movement, this we'll call this delta y, is required to keep us on this indifference curve that we care about, this u bar 1. And we've found the values for all of these changes, and we've calculated the Hicksian demand, keeping us on u bar. And that's everything we need to do to characterize this solution. And it looks like my battery's running out. So I think that's going to be the end here.